Okay, so I've got a new project going here. What this is a 32-bit ST microcontroller dev board. It is the STLINK, and this thing is basically a microcontroller, which is a chip, processor chip, with a bunch of I/O interfaces attached to it. So this one has two CAN bus transceiver interfaces on board. It's got a 4.3-inch LCD with touchscreen, and it's got Ethernet and a bunch of other stuff which I'm not using. And that little board up in the corner there is an I/O expansion board, which I'm not using at this point. The little thing in the upper left-hand corner is a cannable USB CAN interface for my computer, for my workstation. And I've just got the two devices connected with a CAN high and a CAN low cable. It turns out I don't actually need the ground cable between these two things, because I think they're sharing a USB ground bus, or USB bus ground connection to the computer, so I think everything just works fine. So the goal of this project is to develop a gauge or display that shows all of the AEMNet data as it flows over the CAN bus. My ECU in the Supra is an AEM506, and I have a couple of other AEMNet devices plugged into it. And the intro clip was basically this thing just sitting on the CAN bus, daisy chained to one of my aftermarket product gauges, and it works fine. So I'm sort of at a milestone where I've got the code written to actually unpack the AEMNet CAN frames, which are basically like packets, and display meaningful data. So yeah, this thing is actually wasn't too bad to get up to speed. This is my first ever microcontroller project, and the first time I've written any C code in like 20 years. So I'm basically relearning how C works, and also learning from basically zero how microcontrollers work. So the way you program this thing is there's a USB cable that plugs into an onboard STLINK debugger / uploader interface. That's the USB cable right there. And the ST Micro IDE, which is based on Eclipse, comes with the tool chain required to do everything needed to compile and upload and run and debug code on this thing. So that's step one. Eventually I'm gonna move over to like a GCC-based terminal makefile project and get everything working on the terminal. But just to get up to speed and learn how this thing works, I'm using their IDE, which is not great. It's pretty clunky actually, but for what I'm doing right now, it's fine. So the cannable is just shows up as a USB device. It's also got a programming mode, and you can use DFU to program it. But yeah, basically what I'm doing is, before testing in the actual car, I'm just sending byte-packed CAN frames from the cannable to the dev board and assigning all the proper AEMNet IDs with some test data, and this thing actually runs that stuff just fine. So I have a little demo here that I can show you. This is just what I use to test. I'm gonna run the Python script now, and you can see it starts transmitting CAN frames at 20 or 30 hertz or whatever it is, and then the display picks it up and shows you the data. So I think the eventual goal is to have some kind of graphical user interface on this display. Like I said, it's got a touch screen, so I should be able to do some basic functionality in terms of like selecting what you want to see and how you want to display it. I might have some actual round gauges or maybe some percent bars and some text readouts, but yeah, this is pretty fun. So the thing about these boards is they're really cheap. It's kind of, I'm guessing it's a loss leader for ST. This one was $85 and the Cannibal was $20. So for basically $100, I got this very straightforward, very simple dev kit, which I made an entire test harness out of. So running this on the car is a little bit more complicated. I had to make a, let's get this out of the way. I had to make a harness. So I've got a DTM 4-pin, which has CAN high, CAN low, and then 12 volt power and ground to this little USB 12V to 5V converter that I just connected to the harness. And that USB micro just plugs into the same spot that the cable is plugged into now. And that also shares a ground with the CAN network. So it's it works with just this basic harness. I bought one of the AEM Y cables and then replaced that little like white JST style connector with a DTM connector, so I can just plug this thing in right in the dashboard, and it displays successfully with power and data and all that stuff. So yeah, I think all in, this is basically under $200, I would say, including all the materials. One interesting thing about microcontroller development is I'm definitely not a hardware engineer by any stretch of the imagination, but it does require knowing how to wire things and just general knowledge of like how schematics and diagrams work. So this is basically pulls from a little bit of my experience in a whole bunch of different things that I've done over the years. And it only, it only takes like a few, like if you know what you're doing, it should only take you a few hours to do this, but I'm learning completely from scratch. So it's taken me a few days worth of work to like put all this together and get the software running and do all the bitwise operations in C to like get the data off the bus and display it in something a human can read. But if you're good at software and know a little bit about cars and wiring, you can get a project like this up and going for pretty reasonable amount of money. All it takes is time. So hopefully I'll be providing some updates as I progress along this project. This is kind of just like a self-educational project for me. Eventually I would like to get this thing to the point where I could actually use it in the car. I might buy another board, my quote-unquote production board to run in the car and then have one to develop on. At $85, it's pretty good value, so that's pretty feasible. But yeah, I plan on releasing this source code to GitHub. The only other AEMNet microcontroller code that I found on there was a Washington University team, a Formula SAE team that was using an Arduino to pull CAN data out of AEMNet frames and like broadcast it over some kind of wireless telemetry system that they were using. But that was dated 2016, so it's pretty old, almost 10 years old at this point. So once I release that, maybe somebody will find some value in it and maybe contribute. But yeah, I mean, AEMNet is very, very popular, but it seems like all of the stuff that works with it is just super overpriced. I have the aftermarket stuff already. Like I just bought it. I don't mind buying stuff like that on the aftermarket, but anything that you want to do that isn't sort of encapsulated in those products is a bit hard. Like I can't display, what I really wanted to do was display the wheel speed sensors and the traction control, like slip control information, and none of that stuff does it. You have to have your laptop in the car. So the goal of this project is to display all the ECU information I want without needing a huge laptop sitting in the car. Also, these things boot up very fast. They're basically just, like if you press reset, that's how fast it takes to boot up. So it's basically a single application computer, which is why you would use one of these things over like a little board running Linux system on chip or something like that. So it's super fast, super stable, and it doesn't require an operating system. It runs what's called a real-time operating system, but that's basically just a bunch of bootstrapped code that provides accurate timing for your software. So it's more of a middleware type thing. But yeah, anyways, that's basically an intro to the project. So I've hit milestone 1, which is get this thing reading data off the bus and displaying it in a coherent manner. I'm not sure what milestone 2 will be. Probably just getting all the other AEMNet parameters into my frame handling code, and then that'll be milestone 2. And then I think milestone 3 is to get a GUI up, like maybe just some rudimentary gauges other than text on screen. So yeah, at my pace, that probably will take 2 or 3 weeks to get through 2 and maybe milestone 3. Yeah, I'll have little update videos along the way, as well as some more stuff in the car. Like once I get the wheel speed sensor and slip control sensor information in the car, I'll try driving around with this thing mounted somewhere in the car. All right, cool. Thanks for watching. Bye.